So this part of class, my goal is to review how to do energy bar graphs. And these are sometimes called energy flow diagrams. The idea is they need to show conservation of energy, the same total energy before and after at any 2 points in the system. So I drew like a poorly drawn roller coaster here, right? This is like number 3 in the homework. And as this object is traveling, it's got the same mass everywhere, but at A, it has more height than B. What you need to check for your energy flow diagram is what type of energy it is. So I want you to ask yourself 3 questions. At point A, is it moving?
Yes.
If it's not moving, do we know what it does? If it's not moving, what an object would do?
It'll just like stay there.
If it's like not attached correctly, it'll actually just fall straight down, which would be problematic, right? So at A, it is moving. What type of energy does it have if it's moving? Kinetic. So on the answer key, I arbitrarily picked 2 for its kinetic energy and drew 2 bars. So it has kinetic, it is moving. Okay. All right, question number 2. Is it above ground?
No.
So what type of energy does it have if it is above ground? Good, potential. So I normally draw potential in green, and since A is higher above the ground than B, I put A as having more potential energy. So I did this as like 2 and 3. I'm picking these numbers randomly. When you get to an actual problem solving later, you'll have real numbers you can put in here. Right? Yes.
Would you get like points off if you did 3 and 3, or if you did like 4 and 2, or like 4 and 1? Like, does it even matter?
For this one, it doesn't matter. For later ones where I'm giving you a mass and velocity, it would matter, because then you could calculate it. All right. So 3rd question. Is it touching or compressing a spring? No. So no spring potential energy. So this is my first part of my energy bar graph. I have kinetic and potential, but no spring. Right? The circle in the middle is actually telling you the objects in the system. So my hints for you, it's always at least 2 objects, okay? One object is the cart, because the cart is the thing with the mass. Right? What is the other object in the system? We can say the roller coaster. The Earth. Because the Earth is the thing that creates the gravitational field. Right? So whenever you do a problem, it's always going to have at least 2 objects, the moving object and the Earth. And if there's, and if there's a spring, the spring is the 3rd object. Okay, so then afterwards it goes to B. At B, it has less height, so it should have less potential energy than before. Before, I put the potential energy as 3. Let's say the potential energy is smaller. Let's make it 1. Okay. So I have 5 joules of energy at the beginning. I need to have 5 joules of energy at the end. How much kinetic energy has to be there?
4.
4. Yay! So you were asking like, when would you get points off and things? I would give you points for, I think this would be worth 4 points. You'd get a point for the system, right? We named it the cart Earth system. Always at least 2 objects, one of those being the moving object, the other one being the Earth. Then you get a point for your kinetic and potential to start. So your initial energies you've identified. You'd get a point for noticing there's less height, less PEG at the end. And the last point would be that 5 equals 5. The energies should be the same number on both sides. The energy before is equal to the energy after.
Wait, so there's less and there's less?
Yes, because if we take our PEG equation, if there's less height, then PEG would get smaller.
Okay.
And if you do this with real numbers later, it gets easier because you'll be like, oh, I calculated PEG is 12, right? So this one's a little trickier because you have to like make up numbers. All right, so now that we got the method, we're gonna do one more super quick, number 2. And number 2 is tricky because in like the first picture, I've got a mass. It's above the ground, right? But it is stationary and the spring is not stretched. Think of it like this. If I have like, oh, I don't have a rubber band up here. Oh, I do have a rubber band up here. Okay, if I have this rubber band and it's just sitting in my hand and I'm not stretching it, is it storing any potential energy? I have to stretch it from its original length in order to make it store energy. So it is not stretched, but it is above the ground. Right? So let us do those 3 questions. Is it moving? If it's not moving, it has no kinetic energy. You can just put a little 0 over there. Is it above the ground? Yes. So I'm gonna draw for above the ground. I'm gonna pick a new number. Let's make it 6. That's a nice, easy number to work with. So it's got 6 joules of potential energy. Is it stretching the spring? That picture, the spring is kind of just like resting there, right? It's like hanging there. Since it's not stretching the spring, no elastic energy. All 6 of those joules are going to change on their own. All right, objects in the system. This is the mass, spring, earth system. The mass is because it's going to move. The spring is the thing that stores the potential energy later, and the earth gives the gravitational field. Then, sometime later, the spring is stretched out. It's lower above the ground, and it is now moving. So finally, my second picture, it needs to have some kinetic energy, some potential energy, and some spring energy. And I don't care what those numbers are, except that I should see that potential is smaller than 6. So let's say I make it 3. And kinetic and spring together have to add up to be the 6 total. So what if I did it like this? Yeah, so at B, it's moving, like it's heading down and stretching the spring and is still above the ground. Yes.
So was A was like someone holding it up maybe, and then they just like let go.
Mm-hmm. Yeah, so A, someone's like holding it here and then releasing it from rest.
I also thought it might have been like for A, someone just like it was hanging there and someone like pulled it down for B.
Oh, yeah.
I just get a little confused by the thing sometimes.
Yes. Actually, luckily on tonight's homework and stuff, there's no springs in it. They're all just kinetic and potential. So that should help a little bit. With springs, pretty much the only things you're going to need to know are like it stores energy when it's stretched out. And the more you stretch it out, the more energy it stores.